Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video. And actually, it's going to be a bit of a video series, if you will. I'm spending the next few weeks talking about quadratic equations, quadratic expressions, graphing quadratics, things like that. In this particular week, everything just on quadratic expressions. No solving for x whatsoever, no graphing them whatsoever, but what we can do with them. We're going to be combining like terms, doing distributive property, doing factoring, things like that. In this particular video, these are going to be pretty short. In this particular video, I'm just going to be combining like terms. I'll talk about what the rule is, give a few examples, and then I'll be out of here. So let me just show you the one screen. I'm not doing multiple screens on this. Here's the single screen you're going to be looking at for this particular video. Combining like terms, you might have heard it before. In short, CLT. If you ever see any of my videos show CLT, that's what it means. What is this rule? What does it mean? Here's what it says. I'll break it down. I'll make sure that it makes sense and all that. As long as separate terms in an expression have matching variables, and those variables have matching degrees, then the coefficients can combine via addition or subtraction to form a single term of that variable and degree. Okay, so first of all, the word matching comes up a couple times. In order to have matching variables and matching degrees, in order to combine like terms, you have to have matching variables and matching degrees. Now, what are variables? We're talking about your x, y's, and z's and such. Now, does x match with y? No. Does y match with z? No. So if you have something like x plus y, I can't combine these to make something greater than it is or less than it is, because the whole point of combining is to make it simpler. I can't combine these in any sort of way. Heck, even if I have something like x plus 2, this doesn't have a variable whatsoever, so it doesn't match with this variable at all when we do it. But if there was a minus 1 right here, I could combine the 2 minus 1, because those things seem to match. You know, we've been doing 2 minus 1 forever. So they have to have matching variables here, but not just matching variables. They also have to have matching degree. Now, I'll do an example with you later on the matching degrees, but as far as things that, what does degree mean? Another word for degree is exponent. So if you have something like x squared, that is a variable of degree 2, and x cubed is called a variable of degree 3. X is called a variable of degree 1. That means x to the first power. So that's what degree means, exponents there. They have to match with the exponents. All right, then the coefficients can combine via addition or subtraction. So what's a coefficient? When you have a variable, the coefficient is the number that multiplies in front, like this 4 right here. That's what a coefficient is, and we're going to be matching some things up. So I kind of just broke down a couple really quick examples there, and let's do another one. Let's say I have 2x plus 3x right here. This, let's see if this makes sense, and can we combine like terms, and if so, what does it mean? Do we have matching variables in this expression? Yes, both have x. Are they matching degree? Well, they're both to the first power. You don't really see it, but they're to the first power, so yes, they match in degree. So what do? We take the coefficients and we combine them via addition or subtraction. Looks like this is addition, so I'm going to take the coefficients 2 and 3, and I'm going to add them, and I get 5. I formed a single term of that variable and degree. The variable is x, the degree looks like it's 1, so I'm going to keep that. 2x plus 3x equals 5x, and it all matches up right there. Now, why is this allowed? How does this work? Why does, all that kind of stuff. Why are we doing this, and why does it make sense? Well, think about it this way. 2x means 2 times x, and 2 times something means something added to itself twice. That means 2 times x means x plus x. I'm adding one x with another x. Just like 2 times 3 is 3 plus 3. 3x means 3 times x. That means x plus x plus x. It means 3x is added together. If I add 2x's added together with, here's this plus, with 3x's added together, in total, how many x's are added together? That result is 5 x's are added together. So that's all that thing means. That's why the variable is the same with the same degree. That's why the coefficients are adding or subtracting, or in this case just adding. But that's why they're adding, because it describes how many x's are added together. And that's why we can simplify it. And that's kind of what this whole thing's all about. All right, just see a few more examples before we go on to the nitty-gritty down below. Let's take a look at something like this. X plus 2 minus 4x right here. Sometimes what you'll see me do is when I combine like terms, maybe I want to arrange things that are the same. Like I'm going to circle everything that's an x to the first power. I'm going to underline everything that's a constant, something like that. And I arrange the circle things together. X and negative 4x can be right next to each other. and then the plus 2 is written after. This is to make sure that you don't miss anything, so you know what combines, things like that. So you know what sign is applied. It's a negative 4x, not x plus 4x. It's x minus 4x, things like that. Anyway, so this would combine. X also means 1x, guys, and 1 minus 4 is negative 3. That becomes negative 3x. Plus 2, again, the 2 doesn't combine with these because it doesn't have an x in it. Not a matching variable, and definitely not a matching degree. If the variable don't match, then the degree don't match. Don't worry about that. So negative 3x plus 2 ends up becoming that result. And one final example here. Let's see some with different degrees now. Let's look at 5x squared minus 7x plus 2x squared plus 9x. So in this example here, we have all of them have x's in them. That doesn't mean they all combine. I want to add the x squareds with each other, and I want to add the x's with each other. X squareds have degree 2, so I'm going to add 5x squared with 2x squared. 5 plus 2 is 7. That gives me 7x squared. Negative 7x will combine with 9x. Negative 7 plus 9 is 2, so that gives me positive 2x right there. So you start to see what the combining like term stuff looks like. I'm going to do the examples down below now that have these quantities, these parentheses. It doesn't mean very much. In fact, it actually means very little unless there's subtraction involved, but I'm going to go ahead and carry through, and you'll see some larger trinomial sets as well. So let's go ahead and get started down here. These 4 examples, and the video will be over after that. Let's go ahead with example number 1. 5y plus 4 plus negative 2y plus 6. Now, these things are written in parentheses, probably for no particular reason other than maybe to trick you, but also when it comes to subtraction, it'll be important. When it's addition, it doesn't mean that much. In fact, it really just means I could rewrite this thing without parentheses. Now, why did they do it? Again, maybe to be consistent with the subtraction. Also, maybe just to write these little parts in standard form right here. Plus a negative is going to be minus. Standard form means that you're writing your terms in descending order of degree. And like, for instance, here's a quadratic term, and then a linear term, and a constant. They probably just want to keep it in order. Standard form, standard form. So don't let it trick you too much. We are going to be doing multiplication of things later with parentheses. Make sure you understand what it means when there's a plus or minus in the middle, and when there's nothing in the middle. So again, written without parentheses, I'm going to combine like terms. If I do it like the one I did up here earlier, I'm going to reorder these so that they're the y's are written next to each other. 5y minus 2y. And maybe as I keep going, I cross out the ones that I've already used. Plus 4 minus 6, or excuse me, plus 4 plus 6. Plus 4 plus 6. So I used all 4 terms. And I just put them in order so that I know what can combine. 5y minus 2y is going to combine to give me 3y. 4 plus 6 is going to combine to give me 10. So I get 3y plus 10. That's the simplified result right there. All right, let me do one other example here. Well, actually, no. Let's just do the subtraction one. 2 more binomials subtracted. Down here we have d minus 9 minus the quantity 3d minus 1. Now this d minus 9 in parentheses really doesn't mean anything. Once again, I'm not doing anything really to the d minus 9 in parentheses, but now this minus does apply here. And what this says, and I'm going to be doing distribution in my next video, but what this says is I'm going to be applying the negative to every term inside the set. So I'm going to be subtracting 3d, and I'm going to be subtracting negative 1. So if I write kind of an in-between step here, this is minus the 3d minus the negative 1. So I wrote those around parentheses to show that I'm subtracting that grouping that is all of that term and all that term including the negative. So this becomes d minus 9 minus 3d, and then I have minus negative 1. That becomes a plus 1. So basically all you're doing in subtraction of a set here is you're changing every sign that's inside. This was a positive 3d. When I subtract it, it's now a minus 3d. This was a minus 1. When I subtract it, it now becomes a plus 1. You swap all the signs in the set that's being subtracted. That's all. Okay, let's see if we can make sense of this. This is going to be 1d minus 3d. 1 minus 3 is negative 2. That becomes negative 2d. Negative 9 plus 1 becomes negative 8. I get negative 2d minus 8 right there. So that's it, and that's all for that problem right there. Now let's go to the trinomials. Not necessarily harder, just more to do. Just more to do. So let's try these right here. This one's a plus, again, really non-affecting when it comes to the signs. Basically, the signs are what they're going to be. That doesn't mean this becomes plus n squared. It just means adding a negative is still subtraction. This is still a minus. This is still a minus. This is still a plus. So let's rewrite this again without parentheses here, and I will reorder them because there are multiple terms. And then the last one I'll probably try and do mentally with you. Sometimes I like to do some mental practice with people and see if they are able to do it, because that's the way that I do it. And if you can get that far and that good at it, then that's good proficiency. That's really good proficiency. So I'm going to reorder these once again. 2n squared with negative n squared are going to be next to each other. And again, it might help to cross things out along the way, just to say, all right, I've taken care of those. Negative 5n minus 3n are next to each other now. Again, matching variables, but not just matching variables, also matching degrees. The n squareds, the n's, and now the constants, negative 6 plus 11. And then I've taken care of those. So all 6 terms are taken care of. Now let's go ahead and combine like terms. 2n squared minus 1n squared equals 1n squared. Do I have to write the 1? No. Most answers won't show it anyway. You can, but I won't, just to make sure you know they're the same thing. Negative 5n minus 3n is negative 8n. Negative 6 plus 11, that's 11 minus 6, that's 5, positive 5. And that becomes the simplified version after I've combined like terms there. Notice that I am writing them in what's called standard form. Again, descending order of degree. The quadratic term is written first, the linear term is written second, and the constant term is written third. This will be important when we do the next video on distribution and everything else involving factoring. Make sure you write it in standard form. Here, I don't know, maybe you don't know that yet, but that's okay. All right, and the final problem here, we're going to be subtracting. I'm going to try and do this mentally with you guys. See if you can play along with me. Subtracting the items in this set means that every sign is going to change. That means minus this negative will become plus, minus this positive will become minus, minus this positive will become minus. I'm going to combine like terms. I'm going to combine the m squareds. 4m squared, remember this, plus 3m squared. 4m squared plus 3m squared, that equals 7m squared. Remember, guys, big disclaimer right now, do not try this at home if you're not sure what I'm doing. Don't make the mistake of being overconfident doing it if you actually aren't. So don't try this at home if you're not. But hear me out loud what I'm doing and then make sense of it right now. Negative 1m, I'm going to combine the m's, negative 1m minus 10m. Negative 1 minus 10 is negative 11. That's negative 11m. And finally, 2 minus 4. That's negative 2. So it's very possible to do these things mentally, even with the minus there. I recommend that you at least do the rewrite that I did in this one. In like this one right here, when you minus, at least change the signs maybe, and then reorder if you want to. There are a lot of different things you can do here. Some people do these things vertically. If you think of, if you've done systems of equations, you might take this minus negative 3m squared, you might put it down below, something like that, you know? It's up to you. That's kind of all there is to it. All right, so that'll do it for this video quickly, guys. This is Mr. Robinson here. The next video you're going to see is on distribution for quadratics, and I hope that all made sense. Take care.